Here we're going to look at calculus to solve some word problems. So we need to form equations. That's always our first step. Simplify the equations, put them all in terms of one variable. You can't solve it when you've got x and h or w and l, so you need it all in one variable. Differentiate, you make it equal 0, you solve it, and then you also answer the question. You read the question and find out, is it finding the maximum area, the minimum width, is it finding an x value, is it finding a coordinate. Go back and reread your question, make sure you have answered it in context. So here's a question. You've got plastic trays, the bases are being designed, they must have a volume of 108 cubic centimeters, and you've got the x is a square based and the height is h. You've got to show the internal surface area of one tray is given by that formula. Well, let's have a look at this. The surface area, you've got the back of the tray, that's x times h. Now because it's squared, that's also x times h. In fact, all the four sides will be the same, so you've got 4x plus x times h. And then you've got the base, and the base is found up of x times x. So there's your surface area. You've got some volume information. The volume is area of base times the height. We know the volume is 108 because we're told that in the question. Make h the subject, and now we rewrite the surface area out in terms of one variable. So I've replaced the h there with 108 over x squared, which we found in the last green statement there. We then can simplify that, and so that x cancels out. 432 over x plus x squared. We've done part A. We've shown that total surface area or internal surface area. Now we're going to answer the question and find the minimum amount of plastic. So we have an area formula and we need to differentiate that area formula. Now note the x comes to x to the negative 1. So we differentiate 2x, negative 432 x minus 2. Don't forget to reduce the power by 1. The next step is to make it equal 0, because at a minimum we're asked for the least amount. The least is when you get a turning point. Turning points have a gradient of 0. You can then solve for that. I've put there are several ways of rearranging this to find out what your x equals. You divide by 2, find the cubed root 6 centimeters is your answer. Then we put the h. From the previous part of the question, we found that h equals 108 over x squared. So find out what h is. The height is 3. You can write out the dimensions of the question, of the box, 6 by 6 by 3. Is that what we're asked for? We're asked for the dimensions of the tray. And there we have it, and that will give you the least amount of plastic because it's a minimum. You could double differentiate to show that it's a minimum. Remember, when you double differentiate, and if it's positive, you will get a minimum. Perhaps we will check that now. So differentiating, we get 2 plus 864 x to the negative 3. Multiplying negative 2 by a negative number gives you positive. Put the x cubed underneath. Substitute the 6 into there. It equals 6. It is positive, so therefore we have a minimum. Now we're done.